welcome to this small Niska village. Now, one key aspect about the Niska people, or this group of First Nations in particular, is their key reliance on salmon. So we have a village over here, we have this nice creek, and on the other side we have this really big river. Now there's a problem. The people need to cross this creek in order to get to the river, but there's no way to get across. No one wants to get wet while they're on the way to do fishing. So today we're going to help them design a bridge that goes over this creek so they can get to the river nice and dry. So one of the key cultural elements about the First Nations is their respect and their reliance on nature and the environment to give them what they have. And so with this bridge, we're going to try to have the least environmental impact and geographical impact on the surrounding area. In the past, they've built suspension bridges, but in this case, we don't have a span that's very long, and so we're just going to build a basic arch bridge. Now, in graphing terms, an arch bridge is obviously an upside-down parabola. So we're going to find the 3 points that we need in order to calculate the equation for this parabola so we can build this bridge. I already put out the axes for us. The yellow line, which is the water line, is our x-axis. The pink line over here, where the bridge starts, is going to be our y-axis. This orange dot over here is going to be where our bridge starts. As you can see, it's on the y-axis, so the x value is 0. Let's count the y value. 1, 2, 3, 4, 5. It's 5 units above the water line, so our first point is going to have a y value of 5, so it's 0, 5. Now let's calculate the length of the bridge. If you look at the bottom left hand corner of my screen here, you can see that it says 34 blocks affected. That means our bridge is going to have a length of 34 units. You can also see that we have another point here. This is where our bridge ends. And since we've calculated that the bridge is going to be 34 units long, the end of the bridge is going to have a x value of 34. So this point is going to have an x value of 34, and we also want the end of the bridge to be at the same y value as the beginning of the bridge. This way it provides some nice structural stability. You want the bridge to start to end on the same y value. And the y value of the first point is 5, so the y value of this point will also be 5. So this point is going to be 34, 5. Now let's calculate the vertex. This is going to be the very top. This is going to be the highest point of the bridge, and it's also going to be right in the middle of the bridge. And we're going to calculate it right now. So we have this canoe here that we want to pass safely underneath. And let's just say that this bridge is going to be 1, 2, 3, 4, 5, 6, 7, 8. Let's say it's going to be 8 units tall. So we know right away that a vertex is going to have a y value of 8, because that's going to be the top of the bridge. The highest point of the bridge is going to be 8 units tall. But how do we calculate the center? Well, we could obviously do some counting, but we can do this algebraically as well. We calculated 2 points earlier, and if you look at these 2 points, which are listed at the top of the screen, you may notice that they actually have the same y value. And because of this, they are an equal distance apart from the axis of symmetry, which is the x value of the vertex. And this means that we can actually calculate them algebraically with a special formula. And it's the second point of x minus the first point of x divided by 2, which equals to 34 minus 0 divided by 2, which equals to 34 divided by 2, because 34 minus 0 is 34, which equals to 17. So we have an x value of 17 for our vertex, and thus our vertex has a value of 17, 8. Great. We have our 3 points, and now we're going to go and graph it out. Alright, we're here on Desmos. We've got the 3 points we determined earlier plotted out. 0, 5, 17, 8, and 34, 5. And what we need to do is calculate the equation of a parabola that will satisfy the requirements, which means they connect the 3 points. So, this is the equation of a parabola with all the necessary transformations. When there is no transformation, the parabola is actually just y equals x squared. And it's quite different from what we want. This parabola opens upwards. We have a parabola that's upside down. It opens downwards. So right away we know there's going to be a reflection in the x-axis to make this equation open downwards. And the a value is what determines the reflections. And it also determines the vertical stretch. But as you're going to find out later, we actually don't need a vertical stretch. It changes to a negative. we're going to input this here as well. As you can see right away, it flips down a bit closer to what we want. And so what else can we do with this equation? Well, we have the vertex. We can input this. H and K are actually vertex values. H is the x value of the vertex, K is the y value of the vertex. So H, 17, K is 8. We can input this into our equation here as well. Just gotta make a few changes. X, 17 squared plus 8. As you can see, our parabola is now upside down and it meets the vertex a lot closer to what we really want in the end. So we're going to look at this graph here. We don't want the y values to change, right? Because we have the vertex, we have the parabola like this, we have the points connected to be over here. To reach these points, you don't need to change the y values at all. To reach these 2 points on the sides, you're going to want to change the x values. Thus, we're going to be doing something called horizontal stretching. We're changing the parabola horizontally, and that's determined by the b value here. So first of all, let's determine what type of change is going to be needed. Are we going to compress the graph, or are we going to expand it? Using common sense, you can tell right away we're going to be expanding the graph from here to here, and from here to here. That's expansion. So now we got to calculate the b value. But looking at this equation here, we also have an x and y value. We don't want to solve, an equation when there's 3 different variables. That's a bit hard, but we can actually get rid of the x and value right away because you have a 0.05 here. You can input this into the equation. X is 0, y is 5. And this can be simplified a lot more to make it easily solvable. First of all, 0 minus 17 is just negative 17. You also have a plus 8 here. Bring this to the other side. 5 minus 8. That just becomes negative 3. So now we have this negative 3 equals bracket b bracket negative 17 bracket squared. Now it's still somewhat complicated, but we can simplify this even further. Now the first thing you may notice is that you have 2 negatives here. We're just going to get rid of them. They're going to get cancelled out. So you just have 3 equals the bracket. B times negative 17 just equals to negative 17b. We square the whole thing. It's a lot simpler now actually, which is great. It's what we want. Now we can expand this equation over here. Leave the 3 sides the same. Negative 17b squared. Negative 17 squared is 289. B squared is just going to be b squared. Alright, now we're going to solve for b. It's a lot easier to do that now that we've simplified it down from this to this. So you have 289b. So you're going to want to divide 3 by 289. That equals to b squared. You still have a squared here. So for our final step, you're going to square 3 over 289. Going to make it equal to b. And as we determined earlier, 289, the square root of that is 17, because 17 squared gave us 289. So at the end of the day, our simplified equation could actually just be written as a simple square root of 3 over 17. So I've plugged in my b value into the equation here, y equals negative bracket square root of 3 over 17, x minus 17 squared plus 8. It is important to note that we were able to get the correct equation because we had to solve for the b value, which impacts the stretching or the compression and expansion of the graph. It's also important to note that since we square rooted the whole equation earlier, the answer is actually plus minus. Sadly, there's no plus minus button in decimals, but it would be correct to write this as plus minus square root 3 over 17. But if you change this to a negative or you change this to a positive, it actually creates no difference in the graph whatsoever. Great. As you can see, our bridge here is finally completed, meeting all 3 points and going up over the canoe before going back down to the same y level.